Thank you. Hi, my name is Isaac Konikoff. I work at Candela Technologies, and we do network testing, and we use a lot of Wi-Fi. So because of that, I got some toys here that I use at work, and this presentation has got a lot of basic elements in it because it's hard to gauge who's going to be in the room. I know we got some amateur radio enthusiasts, so you're going to see some basic information, but the idea is that we'll get through that, and then I want to have you guys come up and actually get your hands on and try out using some of this stuff. So that's the plan. Let's go for it. Okay, what is the RF spectrum? We're mainly talking about radio frequency, and I'm sure you've seen the diagram like this before, but Wi-Fi lives up here in the 2.4, the 5, and the 6 gigahertz, and then you have your AM, FM also in that range as well. And so RF, radio frequency. And by spectrum, we mean the range of frequencies. And so spectrum analysis is basically visualizing the strength of radio signals across a range of frequencies. And one of the most important things you can learn today is the difference between time domain measurements and frequency domain measurements. So who can tell me what time domain, what piece of equipment do you use with time domain measurements? Use a oscilloscope. It shows you a waveform over time. And then there was this guy, Fourier, and I just recently learned that he wanted to learn more about how heat goes into and out of a building or a structure. And so he started working on equations and math to work on that, and other people helped him develop it. And what you have is the Fourier transform, which basically says that any collection of time domain signals can be evaluated as a summation of sines and cosines. And that gives us the Fourier transform, which allows us to see those signals in the frequency domain. And you have some advantages when you do that. You can see what happens when you have a signal that has a center frequency, if it has any side lobes, or if there's any interference across that range of frequencies that you're looking at. And so a spectrum analyzer is what you use when you look in the frequency domain. And I have a couple of those here today. So the key concepts are frequency, which we talked about. Amplitude is the power of the strength of the signal, and bandwidth. The resolution bandwidth, and I'll have a slide that talks about that. The noise floor and the signal to noise ratio. So you're probably familiar with frequency, amplitude, and bandwidth. In the frequency domain, you can have a center frequency, and then you can have side lobes, and then the bandwidth is how much of that range of frequency around that center frequency. And then, yeah, that's that. And resolution bandwidth is a filter on the spectrum analyzer that allows it to be able to see what's happening in a frequency range. So if you have a wide resolution bandwidth, you can see what's happening across a range of frequencies, but you may miss a lower power signal if it's too wide. So as you narrow the resolution bandwidth, you can make out those secondary frequencies. And a good analogy for this is if you cup your ears. So if you go into a room like the exhibition hall and you hear conversations going around, if you cup your ears, you're narrowing your resolution bandwidth, and you can hear one conversation over here, and you could hear one conversation over here if you point your head this way. Well, you can't really hear both at the same time. If you uncup your ears, you can hear both at the same time, but you can't quite make out what's being said. The noise floor and the signal to noise ratio, again, you can use a crowded room as an analogy for this. If you walk into this room, it's very quiet, and you can hear me speaking. So the signal to noise ratio, the signal is my voice speaking, it's very high. Very good signal to noise ratio because noise is very low. But if you go into the exhibition hall, you couldn't really hear my voice because you hear all these conversations happening at the same time. So your signal to noise ratio would be very small. All right. So at work we use a lot of Linux tools, and our software runs on Linux. And so these are some of the reasons why I feel it's important to see how spectrum analysis relates to Linux. And the tools that I'm going to show you today, the manufacturers have made Linux software that allows you to use their tools, namely on Ubuntu, but I don't know if they run elsewhere, but anyway, you'll get to try it out later. And here's some of the things I'm going to demo today. The first one is this handheld radio, which is just an AM/FM radio, but it's a fun way to kind of get interested in radio frequency to begin with, because you can turn it on and you can scroll through the frequencies and see what stations you can pick up. You can point the antenna different ways and see what you can pick up. So it's a good way to experiment. And then as you get more and more toys, you can do the same with those. So yeah. And then I'm going to switch over to this zoom in screen so I can show you this RF Explorer, which is just a little handheld RF exploration tool that's kind of geared more toward Wi-Fi. And what it lets you see is channel usage, and it has a spectrum analyzer mode as well. So let's see. So this is in spectrum analyzer mode, and you can see that it's picking up the 2.4 gigahertz range, and got some activity there. And then if you go into the menu, you can go down into the Wi-Fi analyzer mode, and then here you can see the channel usage of the 2.4 gigahertz range. And then you can go into the menu, you can change it over to 5 gigahertz, and you can show that as well. The next one that I'm going to show is this HackRF1 in a PortaPack 2. And as a, I don't know, free gift, I have a couple of HackRF1s I was going to randomly give out today. So this one, it's not the same as this. It's basically the thing that I have is a HackRF1 in a case with an antenna, and you can use Ubuntu, you can use GNU Radio to basically program it. And the PortaPack is also fun. If you get a PortaPack, you can install that into a PortaPack. And so this is running some firmware that lets you do all kinds of things. You can transmit and receive. Here I'm just going to receive. You can pick up ADS-B, which is a transponder on an airplane, and it will show you the ident codes on the screen as airplanes fly overhead. And here I have the audio set up, and I have it tuned to a radio station, and if you put it in wide FM, you can hear the radio station because it can demodulate the FM radio signal. And so that's what it looks like. So I'll let you guys play around with that as well. Okay. Then next, what I have is the next three items are the actual spectrum analyzers. I have this one. This one is made by Aronia, and it's got some pretty cool software. I'll show you in a minute. And then I have this one by Signal Hound, which is a Washington company. I think it's a software-defined radio in here, but they have a Linux software package that you can use to control it. And view the frequency domain. And then I have a all-in-one Rigel spectrum analyzer. Here I have it set to the 2.4 gigahertz, and so you can see that we have some activity going on in the Wi-Fi frequency domain. So I'll let you guys play around with that. And some of these are quite expensive, so feel free to play around with it, but please be careful. Some more Wi-Fi related ones. This is a handheld Wi-Fi scanner by a company called Cytos. And there you go. There you go. People use this. You can use this for surveys or other kinds of troubleshooting with Wi-Fi. It's got a touch screen on here to interface with. It's a little clunky to use, but feel free to experiment. This is another Wi-Fi tool that you can use for scanning and troubleshooting. It's called the AirCheck G2. And this one is cool because it gives you lots of information about the Wi-Fi channel as it's in use. And you can upload your packet captures and analyze them later. I have a few other things here. I heard you guys talking about amateur radio, and I got this Mesh-tastic thing, which is kind of fun to play around with, but you can't do much with it unless it's attached to your phone. But here it is if you want to play around with it. And then these two are pretty cool. These are part of the WLAN Pi project, which is a open source project that this group that I work with, the Wireless LAN Professionals, use. And they have a form factor where you can download the image, put it on an SD card, and then run it on a Raspberry Pi, Pi 4. And it's really cool because it has a lot of Wi-Fi tools baked into it. So you can do things like a speed test, you can do scanning, you can even connect up one of these, which is a spectrum analyzer, but its quality is not as good as some of these more enterprise grade ones. So I'm not going to turn these guys on, but they're here if you want to look at them. And what I'll do next is I'm going to show you the software for the Aronia. So this is the main window here, and it's set up so that you can change these grids and these displays. It's pretty configurable, and there is a configuration tool here where they kind of give you a graphical view of what you have set up. It's kind of similar to GNU Radio in that respect. You're putting these modules together so you can get a view of the spectrum that you want, and then once you have that set up, then you can press play, and then you can see the frequency space in use. So here in the blue underneath that top diagram, it's showing all of the Bluetooth low energy channels, and it's also showing the 2 gigahertz Wi-Fi channels. So you can see that we're getting a lot of activity on channel 6 on 2 gigahertz. So that's really it. Yes, go ahead.
What was that called again, that software?
This software is made by Aronia, A-A-R-O-N-I-A. I think it's somewhere on there. And yeah, it's right here, Aronia. And it comes with their spectrum analyzer. I will tell you that these things are pretty pricey, and they do this unfortunate thing where they charge you for each little module. So I was lucky enough to get one of these at a discount, so feel free to play around with it. They can do a lot, and I'm still learning how to use it. So if you find something cool, please tell me. It has like these 3D graphs and stuff to do with it as well. All right, so I am gonna open it up, and if you guys have questions, maybe we'll do questions first, and then let you come up and try some of these things out.